All right, now we're going to work on finding angle measures of a triangle given two angles of a similar triangle. Little more math, little more logic. All right, we are telling you they are similar. That is our given information. Now you've got to find out which angle is corresponding to which angle. All right, so the largest angle in triangle RTS corresponds to the largest angle in triangle DEF. You learned this in Unit 3, corresponding parts. All right, so angle R is congruent, remember the symbols, to, because it looks like the smallest angle, angle F. Well, how do I know it's the smallest angle? Well, good question. I think I might have to do some math. What do you think? So I know its measure. What is the measure of angle F? It's going to be 15 because R corresponds to F. Okay, we can see that the biggest angle in triangle RTS is angle T. And that corresponds to the biggest angle in the other triangle. I have not given it a name yet. In the other triangle, it corresponds to angle D. So what's its measure? Well, it's 100 degrees. Put my little degree symbol here. Okay. If I know the measures of any two angles in a triangle, I know how to find the measure of the third angle, right? We talked about this. I'm going to do my little brackets here. Measure of all three angles in a triangle equals 180 degrees. That's something you can hold on to. Use this. So if I know the measure of all the angles in the triangle add up to 180 degrees, I can easily find the missing angle. All right, so let's do some math. The measure of angle S is going to be, well, 180 minus 100 minus 15. And what does that add up to? 65 degrees. I'll put this in parentheses because I don't expect you to write this down. All right, so angle E corresponds to angle S. I don't even have to math. Measure of angle E is 65 degrees. So let me show you something. I'm going to put a few extra bits in here. Triangle RTS is similar. That little thing means similar. Is similar to triangle. I'm going to name it because things are going to match. FT. We're going to name it properly. Oh, guys, if I didn't make a mistake, you wouldn't know it was me. Okay. FDE. Corresponding angles. Let that sink in for a second. All right, let's go to the next page. Now you're going to find the missing side length giving two similar triangles. We're going to use the information we have and do math. And I've told you this before. We know that the corresponding sides have the same ratio. Excuse me, largest side to largest side, smallest side to smallest, and medium to medium. And I've told you before, use the same shape in the numerator for each ratio. Don't mix them up. All right, so take two pairs of corresponding sides and make a ratio. You did this way back when in Algebra 1 in Unit 4. We took ratios to make proportions, did cross multiplying. Okay, one possible proportion, and I'm going to give you the names. This would be BA over QP, those are corresponding sides, equals BC over, where am I? QR. Okay, so that's our question mark. We know BA and QP. We know they are similar. We are told they are similar. Given two similar triangles, we know the ratios will work. So now we're going to cross multiply. Okay, and instead of a question mark, I'm going to use an X. So we end up with 5x equals 320. Divide both sides by 5, and you get x equals 64. So I can say QR equals 64. All right? Because these are corresponding sides of the same triangle. Let's write that out. Corresponding sides of triangles. Okay? Now, I'll be honest with you. It doesn't matter what you put on top and bottom. Let's play around a little bit. Let's do it a different way. Let's do QP over BA and QR over BC. And I'll put my numbers in. So QP is 40 over 5 equals x over 8. Let's cross multiply. 5x equals 320. You get the same thing. X equals 64. But you notice in my second ratio, and I did this just to show you, I kept the same parts of the triangles on the top and on the bottom as I trip over my words. Okay? In the second one, this ratio, I used the large triangle in the numerator. Now up here, corresponding sides, used small triangle in the numerator. Okay? It doesn't matter as long as you are consistent. You're going to get the math right both ways. All right, let's go to the next page. Okay, now we have polygons. Oh, no, it's weird. No, it's not. The rules don't change. We just have another shape. The rules are the same. The ratios are the same. Okay, we are telling you they are similar, which means they have the same ratio. They are the same scale for every side. So as we say in the notes, same process. Find two pairs of corresponding sides and make a proportion. I'm going to circle the X so we remember that's what we're trying to find. So we know we need QP. So I'm going to put QP here. And what corresponds with QP? BA. All right, and let's fill in. Here we have DE. And, whoops. And this side, 3.6, is ST. Those are all corresponding. Let's do some math, okay? I'm going to circle. So I get 3x equals 14.4. Now I'm going to get my handy-dandy calculator out because I cannot do this in my head. I apologize. Oh, I should be able to. All right. So x equals 4.8. Oh, because I divided both sides by 3. All right. Well, let's do it a different way. Okay. Does it matter? A different setup. Will that matter? That's a good question. All right. This is still BA. And this is still QP. Why? Because I still need a side that corresponds to our missing side, our missing measurement. All right. This is CD. And this is RS. Well, let's do some math. Is this going to be the same? 2x equals 9.6 divided by 2. X equals 4.8. Well, I'll be darned. What this means is you can choose any pair of corresponding sides, corresponding being the key word. You can use any pair to help you find the missing one. We could do BC and QR, and we'll still find the missing side, QP. Let that sink in. All right. Next page. Now we're going to do some word problems. We're going to use what we have learned, all right? A lot of paper, not that much math. I'm just going to let you know that. So we can set up a proportion to find scale models. And you know you've seen this. If you've ever built model cars, model airplanes, you built Lego sets, scale models. Okay, in the scale model of a boat, 1 inch represents 6 feet. And that's how we write the scale, 1 inch colon 6 feet. So the ratio is also 1 to 6. This is where we set up the words. You're going to be doing this in other science classes. You're going to need to be able to convert. So we have inches to feet equals inches to feet. Sure, we can do that. We can also set it up if we want to. We could also do feet to inches equals feet to inches, as long as we're consistent. So we have to answer. The height of the real boat is 18 feet. What's the height of the boat in the scale model? Okay, so the ratio is 1 inch equals 6 feet. We're looking for the height of the boat in the scale model. That is x. X equals 18 feet. Okay, cross multiply. I like to change my colors. So we have 18 equals 6x, divide by 6. Notice how on this one my x happens to be on the other side. Doesn't matter. X. All right. So the height of the boat in the scale model is 3 inches. I'm going to write inches even though it's written down in Alex. So you remember it's not feet, it's inches. Okay, that's cool. So here in the scale model, the length is 4 inches. Now you find the length of the real boat. Change my colors. Okay, we still don't change the ratio on the left. It's still 1 inch to 6 feet. It's still 1 to 6. That doesn't change. But now the length of the boat is 4 inches. We know inches, we don't know feet. I want you to go back to Unit 4 in Algebra 1. X equals 24. The length of the real boat is 24 feet. So when you see problems like this, the first thing you need to do is set up your ratio. You can either do scale model over real, or you can do real over scale. Just be consistent. All right. Next page. Now, finding a scale factor, same units. You're going to play around. Here are the dimensions, and you've got to find the scale factor. Now you need to pay attention to the words. Model to the real sculpture. So that's model over sculpture. If you don't pay attention to the words, your scale factor will be wrong, even though your math is right, and you will get this wrong. So model to sculpture, 8 over 72, and this is 6 over 54, and that is 9 over 81. So 8 over 72 is 1 over 9. 6 over 54 is 1 over 9. 9 over 81 is 1 over 9. So the scale of the model to the sculpture is 1 over 9. That's what we're looking for. Now look how easy that was. And I've got a whole bunch of stuff down here. I could have picked one row. I did all of them. Okay, so here you go. Not that bad. Boom. Here we go. Let's try one ourselves. The table below gives the dimensions of a bridge and a scale model of the bridge. Write the scale factor of the model to the real bridge. Model to B for bridge. Trying to make it obvious. So, model to bridge. Model is 5. See how, notice how this time your things are written left to right instead of right to left. Pay attention. Model to bridge is 5 over 15. over 21, 9 over 27. Let's reduce fractions. This reduces to 1 over 3. This reduces to 1 over 3. This reduces to 1 over 3. So what's the scale? Its model of bridge is 1 over 3. Not really complicated. Last part, last bit of math, okay? Last bit of notes for the day. It's a lot of material, but you can get it done. So now you're going to reproduce, and yes, you are going to be doing this in Alex. So here's your figure. Scale is 1 unit equals 2 meters. Ha 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 ha. Draw the figure with a new scale unit. All right, now you've got to go. Here we go. You need to understand what your real dimensions are. So if 1 unit equals 2 meters, the actual side lengths are 1, 2, 3, 4, 5, 6. 6 units, right? 6 units at 2 meters each is 12 meters. I'm going to do 6 over here. 3. And this is 3 units at 2 meters each is 6 meters. So you need the real scale. All righty? So now that you know the real scale, erase those words. You need to know the real measurements, not scale, real measurements, I apologize. Once you know the real measurements, this thing is actually 6 meters by 12 meters, then you can redraw this. So it's 6 meters by 12 meters. Let's play around a little bit. All right. So here's our new scale. Our new scale is 1 unit equals 6 meters. All right. So let's look at the height of this thing. We don't know how many units, but we know it's actually 12 meters. So cross multiply, 6x equals 12, divide by 6, x equals 2. So we know the new figure is going to be 2 units, not 3. I got a little carried away. The new figure is going to be 2 units, and Alex does not care where you draw it. Just draw it somewhere, all right? 2 units. Now, we've got to find out how far across. The scale is still 1 to 6. We know the real length. We don't know how many units, do we? I'm going to use y. The real length is 6. 6y equals 6 divided by 6. Y equals 1. So I'm going across 1. All right? So the current scale, the original scale was 1 unit equals 2 meters. 1 unit equal 2 meters. The real measurements were 6 meters across, 12 meters high. That's the real measurement of the block. We're going to call it a concrete block, the real measurement of the block. Now, I'm going to take the real measurements and I'm going to draw them on a new scale. My new scale is 1 unit equals 6 meters. So that becomes a 1 across, whoops, and 2 high. Sorry about that, guys. A 1 across and 2 high block. All right, a lot of words, a lot of drawing, but the actual math is not hard, okay? So I think you can do it.